All right, I think we'll go ahead and get started here. Um, as you can see, we won't be doing a problem quiz today. I just try to verbally say what we're doing next week and then try to get this filled in and then on plan book. But even though this is where we start, a lot of the naming of alkenes is very similar to that of alkanes. You just have to name where that double bond is. And then there's also this idea of restricted rotation. And that's something that we will explore a little further in depth next week. And we covered this, I want to say, on, it might have even been on Monday, why this is, or maybe it was Wednesday. I can't remember. Sometimes these days they just all start running together when we're all running in 3 different directions at the same time and nobody's winning. So just try to do the best we can to make it through this busy time. And I would be under the impression it's not going to slow down for any of you seniors. That's just welcome to real life. So hopefully we prepare you well for your next 4 years, 5 years, 6. Now, when we say 4, 5, 6, 7, we're not talking about trying to get through a bachelor's degree saying 6, 7, or 8 years. No, some of you may be going to school longer than that. That's what we're trying to imply by that. And we're not going to be doing a whole lot today because one of the things, it's really, really confusing, I think, what we could be starting next week. And I would rather start that on a Monday rather than trying to explain something like this on a Friday, and then it's kind of like, oh my gosh, now we got to process all this information, and we'll be able to make more sense of that on Monday. I just want to do this one, and then these chemical properties, and then this is where we're going to be starting next week, okay? And we've seen parts of this before, and this exists on alkanes as well, and we'll explain what that means in just a moment. And can you tell me, with the limited amount of time that we've had in this class, what is the difference between the organic sections that you have taken in freshman year, junior year, and now senior year? What might be the difference that you have experienced? And I don't know, maybe you can't answer that because it's something that we just verbally say. And what we mean by that is your freshman year, how many derivatives did you have to know? Okay. Then your junior year, it was those same 2, but then what got added? Propyl and isopropyl. So then we're up to 4. And then what have you experienced that was different? Yeah, your butyl groups, which adds 4 more to it then. Okay? So then it's not only naming these compounds, but it's also maybe more complex derivatives and the reactions that accompany these compounds. And this is no different. And that's what sets this class apart from what we have done junior year. Because you haven't seen a reaction in junior year chemistry. It's just mainly naming compounds. Well, it's not mainly. That is all that we had done, and that's enough. Okay, So then, again, I just want to get through this one. And then there's a couple things I'm going to put up on the board, and then that'll be it for today. Oh my. I think we can agree this week did go by pretty fast. I don't know. I don't think we've ever talked about that before, but maybe in your estimation, it's finally Friday. But I don't know. Monday you went to Salem, right? No, Tuesday you went to Salem. See, my days are run together as well. Monday we went to Arlington. Tuesday you went to Salem. Wednesday we went to Freeman. Then last night you went to Lake Preston or Iroquois. Or did it turn out all right for you? I didn't see the score on the sports. Was it 3-0? Are we? And sometimes we talk about that. Are we happy with that? And I would like to think so. But you probably are. Okay. See that I understand.
It's so boring. It's hard to stay focused.
Okay.
Because it's just you don't expect when the ball's gonna go to the net 'cause it's all one.
Oh.
And then you filter people in and out.
Okay. And that's all part of. And we can apply that same logic to academics. I'll tell you what I mean here in just a moment. Okay, does everyone have this content? It's because once you write this down, I think it's easier for you to remember that. And I'm always a believer in that. And I know when people make out their vocabulary and type it in a computer, if that works for them, that's fine. But I'm just a believer in applying this when you write it down. It's more easy to see. Okay, so what do we mean by that? Okay, well, let's first look at compounds like this. Okay, now if you understand this, to me, you don't have to write it down because you heard me say this before. If you understand it today, you're going to understand it tomorrow. You're going to understand it every time you see that. What we mean by that is this one. I think we probably, we can just do this as well. Okay. So we talk about with double bonds, this cannot rotate around in 360 degrees, not like the compound above, which of course is ethane. So that single bond, notice that you could even do this with your thumbs, these hydrogens, okay? You can turn this one direction or the other and nothing changes. It's always going to be ethane. But that is not possible. I'll do this for most people, their index finger is a little shorter than their middle finger. So with this double bond then, okay, there's no, it can't rotate around each other, okay? So that has a part in this isomerism. Can we make an isomer of ethane? Could we do for propane?
Yeah. No, wait, could you not? No, it's only 3.
Yeah, it's only 3, okay? So can we do an isomer for ethene? No, because we got this restricted rotation. So when we're talking about these cis-trans isomers, we had mentioned that we could say it happens with cyclobutane, okay? If you have a methyl group there and a methyl group here, notice they're pointed in the same direction. So the best way I think to analyze this is always look at what your hydrogens are doing. Since they're pointed in the same direction, that's going to be 1, let's see here, cis 1, 3 dimethylcyclobutane. And of course, that's quite a lot to remember. And if we do, and if we do this, okay, can we be a little more specific with this? What would the parent chain be? Okay, so it's butene, yes. And why are you right when you say cis? Yeah. So we want to apply that logic with these hydrogens. So then what happens if we do that? Do we have a trans or cis isomer? No, no, because we don't have the same type of groups. You have to have hydrogens pointing in the same or opposite directions, and you could even do this, okay? That is still a cis or trans isomer, okay? So this would be trans because we said, like we mentioned, go by your hydrogens, okay? Which one of these would you guess is going to react very easily? This top one or this bottom one? It was one of the last things you wrote down. Why are you right? It has something to do with this right here. Yeah, if this is a single bond, I believe these are called sigma bonds. These are highly, highly, highly stable. So if you want to react with that, which you can chlorinate it, you can brominate it, you can fluorinate it. And we just do iodine. It's just more of a practice. It's probably not very common for it to do that. But should you choose that, this is probably the most common one, chlorination. Okay, and that would be, okay, you have to have something there. You have to have a catalyst. This, on the other hand, does not need a catalyst. Okay, so whether it's something as simple as this, okay, and if we decide to chlorinate that, this will proceed with nothing there because this pi bond here is really, really weak. Okay. Then remember we said we want to write things. If you write this down, fine. If not, we're going to go over it again on Monday. But you would recognize that the very last line or the very last thing that we wrote down was it talked about what? Hydrogen chloride. Talked about water. What else was on there? Okay. Oh, maybe it didn't say. Okay, it says reactants include hydrogen, halogens. Okay, halogen, halides, and water. Okay, so that's probably a little confusing when you see that. Okay, so what we mean by this is we know that the halogens are diatomic. So this maybe looks kind of silly, but we can make more sense of that. Okay. And then, of course, we could do this. Okay, so why would you guess we would write those like that? I mean, because we know that chlorine's diatomic. Okay, that's one of its characteristics. And of course, this is as well. Okay. And then it said what? Hydrogen halides, is that right? And water, okay? So we have hydrogen, and then a halide would be that, okay? And then water, okay? Now, we wrote those in different colors for a very specific reason. And that is, just think if we did a dotted line right down the middle, chlorine sees itself in its own reflection. Who else does that? Yeah, all of these would see each other in their reflection. But these in red, they do not. And the specific nature of that is, okay, when it comes to symmetry, okay, in anatomy terms, okay, do you remember what a sagittal plane was by chance? It could be like down this way, but a mid-sagittal plane then would be right down the middle, okay? So then picture this being kind of very much like that sagittal plane, and in human terms, if you have that mid-sagittal plane, you have an equal left and right side. That's what we call symmetrical. These up top in blue are what we call your symmetrical reagents because it's the same on both sides of the bond. These are called asymmetrical reagents because they don't see each other in their reflection, if that makes any sense. So BR is looking at hydrogen saying it's not the same on, well, let me go the other way. Hydrogen's looking in the mirror and it would see BR. Here it's looking and it would see itself on the other side. This, it does not. Same thing with that of water. And that's going to be very important when we start talking about these reactions next week. So that's why we just want to introduce them now, and then we can apply that next week. All right. That's all I have for today, so we will catch up to you next time.